You know we love to explore all sorts of fascinating topics here. But today, we're going really deep on something that's kind of fundamental to well, the world we inhabit. Really, we're talking about design.
And specifically, we're going to be focusing on architects.
Right, those individuals who really shape our cities, our towns, our homes,
Our built environment.
the spaces we live and work and play in. And we've got an amazing set of sources for this deep dive. Books, articles, interviews, it's all here. Really going to give us a rich understanding. And what we're going to discover is that at the core of what architects do is they're problem solvers.
That's right.
Now, of course, we often admire the beauty of a building,
The aesthetics. Yeah.
the artistry, but behind every really remarkable building, every urban space that works, is this whole process of solving a bunch of complex challenges.
It's a web of challenges.
Yeah.
And architects are constantly wrestling with issues.
Oh, yeah.
I mean, everything from the very practical side.
How's a space going to function?
Yeah. Will it actually work? Yeah. To the more, human experience. How will people feel in this space?
And here's the thing. These aren't your typical straightforward problems, like a math problem where you get one right answer. Our sources are introducing us to this concept of wicked problems, and now that doesn't mean they're evil.
No, it's not about good or bad.
But it really speaks to how messy a lot of design challenges can be.
Absolutely.
You've got unclear boundaries, conflicting requirements, it's always evolving.
Needs change. Technologies change.
And that's what makes this, I think, particularly tricky for architects compared to, say, a purely mathematical problem, because you're dealing with subjective factors, people's opinions.
And the targets are moving all the time.
Right. So give me an example of a wicked problem in architecture.
Oh, well, take something as seemingly basic as designing a school. On the surface, you might think, okay, well, it's just about arranging classrooms and hallways. But it is so much more than that.
I bet.
You have to think about student safety.
Big one these days.
Huge.
Mm-hmm.
How do you create inclusive environments for all kinds of different learning styles?
Right.
You've got to adhere to really strict budgets.
Always.
And then you have to think about, okay, what's education going to look like in 10 years, in 20 years? How do we design for that?
Yeah.
You're dealing with a problem with so many interconnected parts.
And no simple solution.
Not at all.
And to really wrap our heads around the scope of this, our material really breaks down the different kinds of design problems that architects tackle. It's not just one thing.
No.
You've got the functional challenges, like does the space actually work for what it's supposed to do?
Right.
You got spatial considerations, like how do people move through it, interact within the spaces?
Absolutely.
You've got structural integrity. Will this thing stand the test of time?
Gravity, weather, all of that.
Then you got the environmental impact.
How does it affect the planet?
Then you layer on the social aspects, the aesthetics. Does it look good? The regulations, all those building codes.
And then, of course, there's always the economic reality.
The money.
Yeah.
So it's this whole comprehensive landscape.
And what's so interesting is all of these different categories, they don't exist in isolation.
Oh, I bet they're all connected.
Right. So, you might make a decision about the structure of the building that's going to impact what it looks like, how energy efficient it is.
It's all intertwined.
Yeah.
Yeah.
And that's part of what makes this field so fascinating, so demanding.
So that's exactly what we're going to unpack. We're going to look at how architects, what are the tools they use to navigate this complexity?
The methodologies, the techniques.
And then we're going to dive into some really cool real-world examples.
Case studies.
Yeah, to see these principles in action.
Exactly.
So get ready for some aha moments when you see how these concepts turn into buildings and spaces.
Tangible solutions.
So with all these challenges, where do architects even begin? How do they even start to work through this?
Well, a really foundational approach is this idea of the design thinking framework.
Okay.
It's a human-centered process, and it's very iterative.
What does iterative mean?
It means you're constantly going back and refining.
Okay.
It's not a straight line. It's a cycle. So the first step is to empathize.
Empathize.
Yeah. You have to really understand the people who are going to use the space, their needs, their behaviors, their motivations.
So it's not about the architect's ego.
No, it's about the user.
Putting themselves in the shoes of the people who will be in that space.
Exactly.
So you're telling me the initial stage isn't even about sketching ideas.
No, it's about understanding those human needs.
Interesting.
And then once you have that understanding, you move on to define. You clearly articulate the problem. What are we actually trying to solve here?
Okay.
Only then do you move into ideate, which is where you start brainstorming solutions.
The creative part.
Yes. But the key here is to generate as many ideas as possible. Don't judge, just explore.
The more the merrier.
Yeah, exactly. And then comes prototype. You start creating tangible representations of your ideas. Could be sketches, models, even digital simulations.
So you can actually see it, even if it's just a rough version.
Right. And then finally, you test those prototypes with users. Get feedback, see what works, what doesn't. And here's the key. It's not a linear process.
Okay.
You might go back to emphasize, redefine the problem, come up with new ideas. It's a loop.
Constantly refining.
And that's how you find the best solutions.
Interesting. So that iterative loop seems really crucial for those wicked problems we were talking about.
It is. It allows you to adapt.
Now, another technique our sources highlight is root cause analysis. And this sounds like really getting to the heart of the issue.
It is. It's about going beyond the symptoms.
Okay,
So instead of just treating the surface level problem, you're digging deeper to find the root cause.
I see.
And there's some really cool techniques for this, like the 5 whys.
5 whys.
Yeah, you just keep asking why until you get to the bottom of it.
Oh, like a curious child.
Exactly. And then there's fishbone diagrams, which can help you visually map out all the contributing factors.
Okay.
The goal is to understand why the problem is happening, so you can find a solution that actually addresses the root cause.
So if a building has leaks, instead of just patching them up, you'd ask, why is this leaking?
Right. Maybe there's a flaw in the design or the materials were wrong.
So you're finding that fundamental reason.
Exactly. And that leads to a much more effective, lasting solution.
Makes sense. Now, this connects to another concept from our sources, systems thinking.
Yes, this is about seeing the bigger picture.
So not just focusing on the building in isolation.
Right. Architects understand that a building is part of a larger system. The environment, the community, the economy.
So many factors.
And every decision they make has ripple effects.
Okay, give me an example.
Sure. Let's say you're choosing materials for a building. You don't just consider cost and aesthetics. You also think about where those materials come from, their impact on the environment, their durability.
So it's a much broader perspective.
It's about understanding all the interconnected elements.
Now, our sources also talk about scenario planning. And this sounds like thinking about potential futures
It is. It's about being proactive.
instead of just reacting to problems.
Exactly. So you envision multiple possible future scenarios and you design solutions that can adapt.
Okay, so like with climate change.
Right. You might design a building that can withstand extreme weather events or rising sea levels.
That's incredibly forward thinking.
It's about future-proofing our built environment.
I love that. Now, this next concept is interesting, constraints as catalysts. Because, we usually see limitations as obstacles.
Yeah, we tend to think of constraints as something negative.
Right, things that hold us back.
But the idea here is that limitations, whether it's a tight budget, a challenging site, or strict building codes, can actually spur creativity.
Really?
When you have less to work with, you have to be more resourceful.
You have to think outside the box.
Exactly. And that can lead to some truly innovative solutions. Some of the most iconic designs came about because of constraints.
So limitations can actually push us to be more creative.
They can be the spark.
I like that reframe. It's like necessity is the mother of invention.
Absolutely.
Now, our sources also mention co-design and participatory methods.
This is about involving the people who will actually use the space in the design process.
Makes sense.
The idea is that they have valuable insights.
They know what they need.
Exactly. So instead of designing for people, you're designing with them.
So it's more collaborative approach.
And it leads to spaces that are more inclusive and better meet the needs of the community.
I can see how that would make a huge difference. Then there's design precedent analysis.
This is about learning from the past.
Looking at what's been done before.
Exactly. Both successes and failures.
Oh, interesting.
You study previous designs to see what worked, what didn't work, what can be improved upon.
So it's like building on the legacy of design.
It's about not reinventing the wheel every time.
And finally, rapid prototyping. This seems connected to that iterative process we talked about earlier.
It is. It's about testing your ideas quickly.
So not spending months on a design only to find out it doesn't work.
Exactly. You create rough prototypes, whether it's sketches, models, or digital simulations.
Just to get a feel for it.
And you get feedback early on. You identify problems and make adjustments.
Fail fast, learn fast.
Exactly. And that allows you to refine your design more effectively.
Okay, so we've got a good grasp of the techniques now. But to really appreciate how architects solve problems, we need to see some real-world examples.
Absolutely. Let's dive into some case studies.
Okay, where do we start?
How about the Seattle Public Library?
Oh.
This is a great example of how rethinking the function of a building can lead to a truly transformative design.
Right. I remember reading about this. The old library, it just wasn't cutting it.
It was outdated. It wasn't meeting the needs of the community.
People weren't using it.
So the architects, OMA, they really dug deep.
They did their research.
Yeah, they analyzed all the different things a modern library needs to do, all the activities it needs to support.
I see.
And this process, this programmatic mapping, led them to completely reorganize the building.
Interesting.
They created these distinct platforms for different functions. And they flipped the traditional layout.
Looked at.
Yeah, they put the book stacks upstairs and the more active public spaces like meeting rooms and cafes on the lower floors.
That's interesting. So they were thinking about how people actually use the space.
Exactly. They reimagined the function.
And I've seen pictures of that building. It's stunning. It's got that amazing glass facade.
It's iconic. And it really did transform the library.
From a place to just borrow books to a real community hub.
A civic landmark.
Okay.
Yeah.
What's our next case study?
Let's talk about the High Line in New York City.
Oh, yeah. I love the High Line.
This one is all about adaptive reuse, taking something old and giving it a new life.
Right, that abandoned elevated railway line.
Remember when it was just a derelict structure?
Overgrown with weeds,
People wanted to tear it down.
but thankfully they didn't.
A group of activists saw the potential.
Hmm.
And the design challenge was, how do you transform this industrial relic into a public space?
Right, how do you honor its history while also making it something new and vibrant?
And the solution was brilliant. They embraced the wild character.
With all the native plants?
They used a modular system for the pathways and seating.
Mm-hmm.
It's modern, but it also feels connected to the industrial past.
And it's just such a cool place to be, to walk and enjoy the city from a different perspective.
And it's had a huge economic impact on the surrounding neighborhoods.
Really revitalize the area.
It's an example of how thoughtful design can have a ripple effect.
Okay, let's switch gears completely now and talk about the Makoko Floating School in Lagos, Nigeria.
This one is really inspiring. It's about designing for a vulnerable community in a very challenging environment,
Right. Makoko, that informal settlement built on water.
facing constant flooding.
No solid ground.
So traditional building methods just wouldn't work.
And the solution was so innovative.
The floating school,
Built with bamboo and recycled barrels.
a framed structure that could rise and fall with the tides.
And it wasn't just a school, right?
It was a community center, a gathering place.
And it had sustainable features like solar panels and rainwater harvesting.
It was off-grid, self-sufficient.
It was a remarkable achievement.
Sadly, the original structure collapsed in a storm,
Oh, that's heartbreaking.
but it sparked a global conversation about designing for climate resilience, especially for communities like Makoko.
It showed what's possible when you really think outside the box.
Absolutely. It's about adapting to the constraints.
Okay, let's move to a completely different context now. The Bosco Verticale in Milan.
This one is all about bringing nature back into the city.
Right, I've seen pictures of those buildings. They're covered in trees.
Vertical forests.
It's amazing.
Milan is a very dense city, not a lot of green space.
And lots of pollution.
So the architects wanted to find a way to introduce more nature without taking up more land.
And those towers are so beautiful. It's like nature reclaiming the city.
And they have tangible benefits. The plants help absorb CO2 and pollution,
They clean the air.
and they provide shade and cooling.
It's like a natural air conditioner.
And of course, the architects had to figure out how to support all that weight, all those trees on the facade.
It's a feat of engineering,
The Bosco Verticale is a model for biophilic design,
showing how we can integrate nature into our urban environments.
and it's a beautiful solution.
Okay, for our final case study, let's look at the Christchurch Transitional Cathedral in New Zealand.
This one is about responding to a disaster.
Right. After the earthquake in 2011, Christchurch lost its historic cathedral.
And they needed a temporary space for worship and community gathering.
And they needed it quickly.
The architect, Shiro Ban, is known for his work with unusual materials.
Like paper tubes.
Cardboard,
Which seems so fragile.
but it's surprisingly strong. And the cardboard cathedral, with its simple A-frame design, was built very quickly.
And it served its purpose beautifully.
It was a symbol of resilience for the city,
A beacon of hope.
and it showed that even temporary structures can have profound meaning.
Absolutely. So we've seen some really diverse examples of architectural problem solving. What are some of the key takeaways? What have we learned?
Well, one thing that stands out is the importance of reframing the problem,
Looking at it from a different angle.
challenging assumptions.
Like with the Seattle Public Library, they flipped the layout.
Exactly. And then there's the importance of listening to stakeholders,
The people who will use the space.
involving them in the process.
Like with co-design.
Right. And we've seen how constraints can actually be a source of creativity.
Like turning that old railway line into the High Line.
Or building a floating school in Makoko.
Necessity is the mother of invention.
And we've also seen the value of cross-disciplinary thinking,
Architects drawing on knowledge from other fields.
like engineering or environmental science.
And, of course, the importance of iteration and learning from failure.
That's how you get to the best solutions.
No, it's interesting to think about how these problem-solving skills are being taught to the next generation of architects.
Architecture schools are really emphasizing this now.
Design thinking, problem-solving methodologies,
They're giving students real-world projects, community-based projects,
hands-on experience.
and they're encouraging reflection, critical thinking.
So it's about nurturing those skills from the very beginning.
Absolutely.
So as we wrap up this deep dive, it's clear that design, especially in architecture, it's more than just aesthetics.
It's not just about making things look good.
It's about solving problems.
It's about making things work.
It's a blend of art and science.
Creativity and rigor.
And empathy for the people who will use the spaces.
It's about creating a better world.
And in a world that's becoming increasingly complex, these design thinking skills, these problem-solving skills, they're more important than ever.
Absolutely.
Whether we're talking about the buildings we live in, or the cities we inhabit, or the challenges we face as a society, design can play a crucial role.
It can help us find solutions.
So it's not just about fixing problems, it's about designing a better future.
A more sustainable future.
A more equitable future.
A more beautiful future.
And on that note, we'll leave you with this thought. How can you apply these problem-solving principles to your own life?
To your own work.
to the challenges you face.
Think about it.